All right, so again, the properties that we talked about on Friday: addition property, subtraction, multiplication, division, distributive, substitution, reflexive, symmetric, and transitive. These all properties can be used with equal signs only. We talked about the properties of congruence the other day. We're going to talk about them one more time. These can be used with congruent symbols. The reflexive property of congruence. Again, we wrote this down on Friday, but we're going to rewrite it again just to make sure we understand them. For any segment AB, the reflexive property is basically going to say that segment AB is congruent to itself, segment AB. Nothing changes. It's exactly one segment congruent to itself. The symmetric property of congruence says if I have segment AB and that is congruent to segment CD, the symmetric property says I can just change the order of those and I can say that CD is congruent to AB. Nothing else changes but the order in which I write those segments. And then you have the transitive property of congruence, which involves three parts. So if segment AB is congruent to segment CD, and segment CD is congruent to segment EF, then what can I say? That segment AB is congruent to segment EF, yes. Take out that middle one and put the first and the last one equal or congruent to each other. Everybody okay? All right. All right, so the definition of congruence, this is going to be another reason that we can use in our proofs. We should not have phones out. We should not be on any kind of technology whatsoever. Let's make sure they are put away and not in our sight. So, with the definition of congruence, I can say that if segment AB is congruent to segment CD, then they're going to have the same measure. So what we do is we say that the length of AB equals the length of CD. So you have to pay attention to the difference in the way that we wrote that. I'm going to give everybody a minute to write it down so I can talk about it. Some of our properties only work with equal signs. So like everything that's listed at the top only works with equal signs. The only ones that we can use with congruent signs are the reflexive, the symmetric, and the transitive. If I'm not using those properties, I would have to change it from a congruence statement saying that segment A, B, and segment CD are congruent to then saying that the length of AB is equal to the length of CD. Okay, completely two different things. Congruence is talking about the same size, the same shape. Equal is talking about this length equals this length. Equality is a number. Okay, does that make a little bit of sense? Therefore, we can also go backwards. If I tell you that the length of segment AB equals the length of segment CD, but you're asked to prove that they're congruent, say, for example, then I can say that since they are equal to each other, they are also congruent to each other. Okay, Okay, so we will be using the definition of congruence quite often in our proofs. Another definition that we will use in our proofs is the definition of midpoint. It says the midpoint of a segment divides the segment into two equal or congruent parts. So if M is the midpoint of segment AB, then we can say, okay, think about this. Let's draw a picture. If M is the midpoint of segment AB, then what two segments are congruent? Look at that picture I just drew. M is congruent to MB. So if you have a midpoint, you can tell me that two segments are congruent. Okay, actually, scratch out the equal part. It says that they are congruent. Go back in your definition. Scratch out the equal and leave the congruent there. Okay, if I tell you you have a midpoint, you should be able to tell me that you have two congruent segments. And then from the congruence, you can say equality. Okay, make sure you scratch out the word equal. It's congruent. Is everybody ready? So we can use the definition of congruence. That means if I have two things that are congruent, I can say they're equal. If I have two things that are equal, I can say they're congruent. We have the definition of midpoint. So if I say that something's a midpoint, you can tell me two congruent segments after that. The first postulate that we have discussed is the postulate called the segment addition postulate. If A, B, and C are collinear and point B is somewhere between A and C, then we can say, do you remember I did this with the markers, that segment AB, that one right there, plus the other segment BC would equal, what's the name of the whole segment going to be? AC, yes. Okay, so two small segments can add together to equal a large one. So AB, the yellow highlighted one, plus BC, the blue highlighted one, equals the whole thing AC. Now we're going to start slow with our proofs. We're going to start with some segments, but we're going to then turn it into some algebraic proofs. But then tomorrow we're getting into our real geometric proofs, so we've got to be prepared for that. Is everybody ready? No? All right, let's look at our picture up there. I have a segment, don't I? What's the segment called, the big one? AC. All right. And then what did we say the very first step in our proofs was always going to be? The given. What is given to me? All right, so guess what we're going to write for the first statement? AC equals 12, right? And what's the reason for that? Because it's given. I should never have to think about that first step. It's always the given part. Excuse me. The last statement, we're not there yet, but my last statement is going to be what I'm trying to prove. Okay, so keep that in mind. That very last statement should be what we're trying to prove. Is everybody ready? Okay. Now, other than knowing that AC equals 12, am I given any other information? Am I given a picture? Yes. So your picture is part of your information. So if you don't have enough given to you in your words, you have to then look at your picture. What else can you tell me about AC? It's got 3 points on it. Okay, yeah. What are those 3 points? A, B, and C. Okay. Anything else we can tell? So it's equal to 2x plus x plus 6 because you're taking those and adding them together. Yes, we're going to get there. Okay. I need something before that, though. Hint. It's got two segments, right? What two segments are in my picture? A, B, and B, C. And what did that postulate just say? That we could take two segments and add them together and set them equal to the big segment? Okay. So AB plus BC is going to equal, what's the whole thing called? AC. What is that postulate called? The segment addition postulate. So guess what my reason is going to be? The segment addition postulate, yeah. So segment if I can get my pen to write, sorry, it's not working properly. Whoops. All right, so here's the thing. Is just a second ago, Joey told me that 2x plus x plus 6 was equal to AC. That is correct. But do you remember when I told you that you cannot assume that I know anything about geometry when we're doing proofs? You have to tell me everything. So before I can say that 2x plus x plus 6 is equal to AC, I have to know what the segments are that are adding. So that's why we had to add in that step, AB plus BC equals AC. Okay, you had to tell me that this segment plus this segment equals the whole segment before we can talk about their values, if that makes any sense. Okay, now, if I have that AB plus BC equals AC, let me ask you this. What else do you know about AB if you look at your picture? It equals what? It equals 2x. So could I take AB out and put 2x in its place? Okay. Then if I bring down my plus sign, what else do you know about BC? It's equal to x plus 6, so I can take that out, correct? And then what else do you know about AC? It equals 12. So let me ask you this. If I took away AB and I replaced it with what AB is equal to, I took away BC and I replaced it with what BC is equal to, and then I took away AC and I replaced it with what AC is equal to, what did I just do on all three of those? Substitution. Okay, so we used the substitution property. I replaced one thing with something that it is equal to. Ready? If I were to solve that equation now, this is now turning into an algebraic proof. What would I do first? Combine your like terms, okay? In this book, they call combining like terms the distributive property. Okay, so what two like terms am I going to combine? And so that's going to give me, and again, we're going to call that the distributive property. Anytime you combine like terms, they call it the distributive property. Okay, think about solving that equation. What would I do next? Subtract the 6. And so that's going to end up with 3x equals, and what did we do to get there? Subtracted. Excuse me. Where am I trying to get to? What is my last step supposed to say? X equals 2. Is that what I'm going to end up with? Yes, and I get there by doing what? Dividing. So again, you have to start with what's given. That's your first step. Your last step is always what you're trying to prove. But you have to justify every statement in between. You cannot go straight into saying 2x plus x plus 6 equals 12 because I don't know the segment addition postulate. I don't know that you can take AB plus BC and equal AC. That's why you have to make sure that you tell me that. You're teaching me in these proofs. Seems a bit difficult, yes? It's a lot. It's different. All right, we're starting on the next one. I'm going to give you a minute. I want you to do the very first step in reason. Fill in your first statement and your first reason. Well, first statement, first reason is always the given, so fill it in. Your very first statement is always the stuff that is given to you. What does it say next to given? B is the midpoint of AC, so that's exactly what we want to write. Word for word, exactly as it's written next to the given, next to the word given. Okay, I don't have to think of anything. I don't have to change anything. All I do is recopy this given statement here. So B is the midpoint of segment AC. And that is because it is given. Everybody ready? Okay. Now, it says something about midpoint, so let me scroll back. The definition of midpoint says it divides a segment into two what? Congruent parts. So guess what I'm going to name right now? Perfect. Segment AB is congruent to segment BC. Okay. The definition of midpoint just said that a midpoint divides a segment into two congruent parts. So what's my reason? The definition of midpoint, exactly. Are we kind of okay? Now think about, we're trying to prove that x equals 6, so I'm going to have to set up an equation. Let me ask you this. What else do you know about AB? It equals 2x plus 6, but am I allowed to use substitution for congruence? Is substitution one of my congruent properties? No. So before I can replace AB with what it is equal to, exactly, we're going to have to use the definition of congruence now. Okay, so we're going to have to say because AB is congruent to BC, then we can say that the length of AB is equal to the length of BC. And that is the definition of, what did we call it? Congruence, yes. And don't worry, we're going to do enough of these over and over again that you'll start getting the habit and the idea of what it is you're supposed to do. Okay. Now we're ready to substitute. What is it AB is equal to? Okay. What is BC equal to? And again, that is substitution. I replaced AB with what the picture told me it was equal to. I replaced BC with what the picture told me it was equal to. And now I need to solve this question. Solve the equation. How do I solve 2x equals x minus 6? Okay, well, my x's are on other opposite sides of the equal sign, so we don't really want to combine them. We want to take the x over to the 2x, so that's the inverse, and how do we move that x over? Yeah, like look at this. If I had this 2x equals x plus 6 over here, I would have to subtract my x over, and that does give me the x minus, or x equals 6, and I got that by subtracting. So we are kind of getting our terms together, so we're kind of combining them, but because they're on opposite sides, we have to do the inverse, and that's the subtraction property. Did we get to where we were supposed to? Did we get what it says to prove? Yes.